Okay, we're recording in a moment. There we are. Back to the PowerPoint. So we're going to talk about acids and bases. An acid is a substance that releases hydrogen ions. This is a hydrogen ion right here. This is hydrochloric acid. So when hydrochloric acid dissolves or dissociates in water, it releases hydrogen. That's an acid. A base like sodium hydroxide, when it reacts with an acid proton or a hydrogen atom, it's going to form water, and sodium will be dissolved in the water solution. When you clean your ovens and you have a product you spray on the grease that contains sodium hydroxide. pH is the measurement of the amount of hydrogen ion in solution. So neutral solutions are 7, acidic or below 7, basic or above. So the pH is a measure of how much hydrogen ion is dissolved, and the pH of the body is between 7.35 and 7.45. If your pH is not maintained in your body, that's definitely a big problem. So if you look at a pH scale from extremely acidic to extremely basic, there's oven cleaner, household ammonia, bleach, ocean water. So they have high pH levels, and they have a lot of dissolved hydroxide. OH is called hydroxide. Hydrogen ion is called a proton. The hydrogen atom, H plus. So you can see that stomach hydrochloric acid is very strong. Saliva is around 7.3 or 6.3 rather, and beer, wine, pickles around 3. So vinegar around 3, hydrochloric acid a very, very low pH. It has a great number of dissolved hydrogen ions. Okay, as I just mentioned, buffers in the body maintain the pH between 7.35 and 7.45. If the pH goes up, hydrogen is going to be released into the body fluid. If the pH is too acidic, goes below 7.35, those hydrogen ions will be reabsorbed to return the pH to the proper level. We already talked about salts. Any ionic compound not containing hydrogen or hydroxide, because if it contains hydrogen, releasable hydrogen, it's an acid. If it sodium hydroxide, if it dissolves and produces hydroxide, it's a base. Salts are electrolytes, meaning their solutions in water can conduct electricity. Sodium chloride is the classic salt. Electrolytes carry electrical currents. Sodium chloride and sodium in the body with calcium, potassium, there are currents. There's electricity moving all the time in your body. Organic compounds. So we're going to cover carbohydrates, sugars, lipids, fats, proteins, and nucleic acids. So there's 3 types of carbohydrates: monosaccharides, disaccharides, and polysaccharides. Make sure you know the glucose is a monosaccharide. Disaccharide is table sugar. A polysaccharide is when you join a large number of glucose molecules together to make long chains. That's a polymer, so that's a polysaccharide. If we look at how chemists represent glucose, this is the simplest way to represent glucose. This, with all the atoms added, this is the chain form. So glucose has 1, 2, 3, 4, 5, 6 hydrogens. Carbons, and uh, 11 oxygens. 11 hydrogens and 6 oxygens. 1, 2, 3, 4, 5, 6. Okay, this is how you don't have to know this. You just got to be able to recognize it. If you take two sugars and put them together, that makes sucrose. If you remove water, here's water, H2O. If that water is removed, so the sugars are dehydrated, so that's dehydration synthesis. You should know that. There'll be a bunch of questions on dehydration synthesis. So when you remove water from a glucose and a fructose, a new bond forms, and the water is released. That's dehydration synthesis. If you have sucrose and you eat table sugar, as we all the time do, and if you add the water back into the fructose and the glucose, that's called hydrolysis, which means to break with water. As I said, if you join a large number of glucose molecules together with an oxygen bond, that's a polymer. It's called glycogen. Glycogen is how glucose is stored in your liver. Go through this chart, make sure you read it all, and make sure you're aware of these facts. Lipids are fats. They're water insoluble. There's 4 types of fats: fatty acids, fats, steroids, and phospholipids. We're going to talk about phospholipids in relationship to the cell membrane. So fatty acids, an example is lauric acid, absorbed in food. Fats like triglycerides, that's how fats are stored. Cholesterol is a structural part of cell membranes. It helps make up the steroid hormones like testosterone, progesterone, estrogen. Those are some of the classic steroid hormones, the sex hormones. And then we're going to talk in much detail about phospholipids. So black represents carbon, blue is hydrogen, and red is oxygen. So a fatty acid is a long chain of carbon and hydrogen joined with a carboxyl group. This is a carboxyl group. C double bond OH. If a fatty acid has all of the hydrogens it can bind, that's a saturated acid. If there are some double bonds where all of the slots for hydrogen are not used, that can change the shape of the molecule and give it a whole nother set of characteristics. If you take 3 fatty acids and use dehydration synthesis to attach those 3 fatty acids to a glycerol, so 3 fatty acids, water is removed, you have a new bond formed, new covalent bond. So if you take 3 fatty acids joined to glycerol, that is a fat or a triglyceride. Dehydration synthesis removes water from the fatty acids and the glycerol, forms a new bond. You put 3 fatty acids on a glycerol molecule, that's a triglyceride. That's fat. Cholesterol molecules, on the other hand, have 4 rings. They're the building block of steroid hormones such as testosterone, progesterone, estrogen, corticoids, where you get anti-inflammatory cortisone. So This cholesterol with its four rings is very easy to recognize. And also, it makes up large portions of cell membranes to give the cell membranes flexibility. Phospholipids make up the cell membrane, and two fatty acids and glycerol. It has water soluble and water insoluble parts. So a phospholipid molecule is over here, a diglyceride. It has two fatty acids. Okay, two fatty acids. And my glass just fell off of my desk. Okay, I hope it's empty. So if we look at a phospholipid, it has two fatty acids, so it's a diglyceride. It has a very a phosphate group, and it could be nitrogen. As soon as you see oxygen, you know this is the polar part. So the phospholipid has a water-soluble polar part and a water-insoluble hydrocarbon. Notice there's only carbon and hydrogen. If when you say the word octane, that's gasoline. Gasoline is carbon and hydrogen. So this is the water insoluble part of a phospholipid. This is the water. No, this is the insoluble. This is the soluble. This is the insoluble because this is a fatty, greasy. These tails, these two tails, and they don't dissolve in water. This part will dissolve in water. Okay, let's stop there, and we'll finish up with proteins, and that'll be about it.